Yeah, based on the theory is where you establish your model. You can test or not. You will see the best way, the best practice will be test different model and see their fit until you design the final model. Then then we will talk about why this is the case, why it's the way we need to do this type of analysis, because they're based on correlation, as I mentioned before. Since we know correlation, relationship can go both ways. Even if it's a good fit of your model, the other way, one can also be true. You don't know. Okay. Now, this is where we put everything together. We have this part of the model, it's a path analysis, because we're explaining relationship with direct arrow within this. But this part where we have health-related quality of life that is explained by these three variables and characteristic of individual that is explained by education, this is the confirmatory factor analysis. This is where we put everything together, and this is what is called a structural equation model. We have these two techniques, the path analysis that can be a standalone technique. We have confirmatory factor analysis. If I delete these 2 hours where to the dependent variable, these are, and replace this by the correlation, this is completely confirmatory factor analysis because I don't have direct arrow going to dependent variable. Okay, how this work? The first thing, you have to know your model. And knowing your model, this is based on theory. You have to do a literature review to know about the topic and to know to see what people are saying about the relationship between the variable and come up with a model. We need a model once we be able to graph of the model so that we understand what we are doing. Once we have the model, we need the raw data, or we need a matrix of correlation and the number of participants in order to estimate the model. What the model is doing when you are estimating it is saying this is the pre-established structure of relationship between the variable. Let's try if with the correlation, the matrix of correlation, we can reproduce the structure. And if them within the model, there will be some way of telling you if this is a good fit, if your data fit well the model. That have a lot of implication because we, as I mentioned many times, we're working with matrix of correlation. Relationship can be both ways. That means even if you get a good fit of your model, it can still be the case alternative model are also good fit. Then you have to estimate things in alternative model and estimate them in order to be able to show to your reader, your reviewer, that why you decided this is the final model, the best model. Then that's one implication because we're working with correlation. The other implication, remember, is the model trying to reproduce if the matrix of correlation adjusts with the model. Then the matrix of correlation is based on your data. It's based how good the data fit the model. Your result is a function of the data. What happens if you have different data? will the model still hold? Then, then that's where sometimes replication are needed to have the of of for the final model. Let's say I can actually estimate my model using a sample of students. I do some interview, get data from them, and I estimate my model. It can be true that the model is true for the sample of students. If I go out and interview other people, professional in the daily life, will the model hold? I don't know. We need replication in order to be able to get a final say on the model. Okay. Is that understood? This is the limitation of the technique. It's a powerful technique, but these have some this kind of limitation. Then these are the steps we have to consider in order to estimate the model. The first thing is the model specification, that based on the theory, I have my model, I know the relationship between the models. Then the model identification, we will talk about that. And that will result in, this will be a structure of equation, a system of equation that we're trying to solve, and we will have this rule of the number of equations cannot be greater than the number of unknown. Then we will have to see if the model is identified or not. You can have a model that's not a function of the data. That's different of a function of the data. This is a function of the number of relationship, the number of parameters within your model that you want to estimate. This is pure math. If you don't have that many equations, you cannot estimate your model. Then, once you see that your model is identified, then you can estimate the model. Once you estimate the model within the same software that you'll be using, there will be some gooseness or fit of measure that you can use to actually say, is the matrix of correlation are reproducing the model? How good is your model? There will be some gooseness or fit variable that we can use. But even that, if you do that, and you get, oh, it's not fixing, it's not fitting well, but there is things that you can do in the model, like eliminate some of the relationship, some of the error, eliminate one of them, and see if the model improves. There should be what we call model re-specification after you estimate the model and the way to improve the model. The model specification, we talk a lot about it. You already know about it. This is, I repeat, this is based on theory. You have to know the theory to come up with a model. The model we were talking about is based on this theory of health-related quality of life. That's a huge model. We only take a few part of it that we were estimating. But this is a model that is used for people that are doing this kind of that work in the topic of quality of life. This is a famous model that people try to reproduce. That exists in the literature. Then you can actually take this model and collect data or find data in order to see how you can estimate it with your data. Then this is the model. I already explained it. Yeah, we have life satisfaction, that is related with these two latent variables that we talk about and how we measure each of the latent variables. This is one model. Someone might say, I don't believe in this relationship. Then let's take out this relationship. Still the model. Yeah, you can estimate this model and find, oh, this relationship is not significant, is not, then you can take it out of the model. But you start with a full model based on the literature, but it's, and sometimes it might be you come up with the model, or you can probably take a model from someone, improve it, and then estimate. Yeah, the identification space is important because it's the number of equations should be equal of the number of unknown, or the number of equations should be greater. You cannot have more parameters you want to estimate on the model than actually number of equations that you have to estimate them. This makes it different. Remember, when we do regression analysis, we say a variable is significant or not depending on the number of observations that I have, the number of degree of freedom, then n minus the number of coefficients that I'm including on the model. I need to have enough degree of freedom so that I can estimate my model. The degree